Okay, so 3.8, derivatives of inverse functions. Derivatives of inverse functions. So what is an inverse function? Do you remember, I know, it's been like a year. So when the sine of pi over 2 is 1, right? So if you take the sine value of pi over 2, which is 90 degrees, it's 1, because this is 0, 1, and the sine value is the y value of a unit circle. So then the sine inverse of 1 gives you this answer, pi over 2. So an inverse is when you switch the x and the y, okay? Be really, really careful, because I know that we write this for variables. So x to the negative 3 is equal to 1 over x cubed. That's true, but this is not a negative 1 power, okay? So be careful for sine, cosine, all these things. That's not a negative 1 power. That's denoting that you have an inverse function, all right? And inverse functions is when you switch the x and the y. So just be careful of that. Sine inverse is referring to an angle measure. Yes, your answer to an inverse is always an angle measure, like 90 degrees, pi over 2, those are angle measures. And these are not the same because, remember, that's not a negative 1 power. Okay, so just things to remember. All right, and then I know this is, seems like a lot, but you guys are lucky. So this year, you don't have to memorize all of them. Usually you have to memorize like literally all 6. And then there's a quiz. And then you have to write down all of these derivatives. But this year you're gonna go ahead and you need to know this one, okay? Go ahead and make sure you always highlight the way I highlight, but you need to know this tangent inverse derivative. The tangent inverse derivative you see all the time on the AP test, on all the worksheets. I'm gonna keep asking you this all the time. Once in a while you'll see this, like after this chapter's done, you might see this again, but you'll for sure see tangent inverse. This is on the AP test almost every year. I have seen this, but I mean, if you need to know this, you can always, like, for you guys, you can look it up, okay? This is very common. You have to know, like, from this answer choice, you have to be able to go backwards. You know how sometimes you have to go backwards and think about, oh, where did that come from? So you'll see eventually. Okay, so I want to show you how this works. So the first one we did together, but I still want you to, kind of see it. So the sine inverse of 3x squared. So the sine inverse of 3x squared, I just follow this, 1 over the square root of 1 minus. So 1 over the square root of 1 minus, and then you take that quantity and then you square it. So that's box squared. And then times box prime. Notice all those box primes. So times 6x, and then plus derivative of 2x is 2. Okay, so you can't just leave it like that. You want to, simplify it. So that 6x goes on top, and then you just square 3x squared, which is 9x to the 4th, and that's your final answer. Okay, example 2 is, first step is fine, and then after that, you gotta do some work to it, okay? After that, it's more like algebra. Okay, so here you go. The derivative of a secant inverse is 1 over, you look up at the top, there's an absolute value of the box, there you go. There's a square root of box squared minus 1, so it looks just like that, no problem, I'm just inputting, times box prime. Okay, so there's 2 ways to get the derivative of 2 over 3x. One way is to realize that this is 2/3 x to the negative 1 power. If this is 2/3 x to the negative 1 power, what's the derivative of that? The negative 1 comes forward, you get 2/3 x to the negative 2 power. So you can think of it like that, or you can do LODI high less Heidi low denominator squared below. Obviously, this one's faster, so I did that one. Okay, so from there, the problem with this is that there are fractions in a fraction. So we gotta figure out this complex fraction. We gotta figure out this inside first, actually. So let's do that. So in my next step, I cleaned this up. I put that x squared on the bottom. And then I took away the absolute value, and you can't just take it away. The reason why this is no longer an absolute value is because it tells you in the problem x is between 0 and 1, which means x has to be positive. If x is positive, then I don't need the absolute value anymore. You would never write absolute value of 10, correct? You would just write 10. So it's the same kind of thing. So if I don't need it, then I'm not going to write it. But if this wasn't there, then this would have to have an absolute value still. Okay. And then what happened? I squared the 2 and I squared the 9 or the 3x and gives me 9x squared. And then in my next step, I'm going to deal with this part over here. So you can see in the next step, this 4 stays, the denominator stays, the 1 becomes 9x squared over 9x squared. Okay, why the heck would I want to do that? The reason I'd want to do that is because now I can take out from the square root, I can take the square root of 9x squared. What is the square root of 9x squared? On the bottom, it's going to be a 1 over, right, because it's on bottom. It's 1 over 3x. So I wrote it like this, but ignore all the crosses, okay? So this is the same. Right between here, I now have a 1 over 3x because I factored out the denominator under here. And I not factored it out. I took the square root and I got a 3x. And then this is the same over here. Okay, so what are all the crosses? You can probably figure out the crosses. So there's a 2 divided by 2. I divided those away. This is technically negative 2 times 1. And this is a 3x squared as a denominator. So really, this is 3x squared over 1 as a denominator, because this denominator has fractions, so I'm making this denominator have a fraction. And then you can tell this 3 and this 3 can divide away. The x squared can divide these 2x squares away. So this is an x and this is an x, and they can divide away because this is a numerator and these are denominators. I'm saying this is a numerator of the whole denominator, right? Okay, so then after that, it's been cleaned up. And then final answer. How did that work to be a final answer? There's a negative. On the bottom, there's your radical. And then I look and I look and I look and there's a 3 over here. So really, I have 1 divided by 1/3. What's 1 divided by 1/3? It's 1 times 3 over 1. So that's why this 3 as a denominator of the denominator becomes a 3 as a numerator, right? So this step right here, is like, okay, I'm just going to use my formula, no problem. From there, you're using algebra, maybe some algebra 2. You're cleaning it up, and I know it takes a little bit. It takes some thinking, but that's why I'm showing you that first time, okay? Okay, so now I'm going to call this easy and hard at the same time. So it's hard to say if this is easy or hard. But I will remind you, derivatives of inverse functions. There's a couple ways to do this, but one way is not going to work for us, and one way is the easiest way. Here's the easiest way. Ready? So let's say they want you to find the derivative of the inverse. So to find the derivative of the inverse of this, how do you take the inverse? Oh yeah, I switch the x and the y, and then I solve for y. This is my inverse function. So this is my original, this is my inverse function. If I have to take the derivative of my inverse, now I just take the derivative of that. Done. Okay. But sometimes you're not given something like that you can work with. Instead, you're going to be asked it in a weird way. Here is the weird way. So let's say g is the inverse of f. So you have a function f, and then we're calling g the inverse, okay? You want to find g prime. So this is the one that you should focus on, and that's the one that you should use. So that's what you really want to use, okay? So this says, if the point is on f of x, so I really want that point to be on f of x, then the derivative of the inverse of f, right, that's g prime. The derivative of g is the inverse of f, is going to be 1 over f prime of x. So I want to show you why that works, even though some of you might not care. I want to show you why this is true. So g of x inverse of that by definition. Okay, so by definition, if you have the g of f of x, you should get x, right? So like an inverse, when you put one into the other, so when you take f of f inverse, you always get x, right? Because the inverses, remember, they're symmetric over that diagonal line, okay? So this was always true. So when you take the derivative of both sides, so you're taking the implicit, okay? Derivative of this side is going to be g prime f of x times f prime of x. Derivative of the right side is 1. Now, if I want to find g prime of this, then g prime is 1 over, you divide and you get 1 over f prime of x. So I just showed you why that is true. Okay? So this part, I love, love, love. The reason this is here is because, you know, I want to be thorough, but this is all I really need. So here's the thing. The only difference between this one and this one is right here. There's like a y. So the reason why this turns into a y is because if you have a point on f of x, you're using that x value. If you have a point on g of x, what is this compared to this? It's the inverse. So what is the inverse? X and y's switch. So that's why instead of using the x value in here, you're using the y value in here. Because if this point is on here, then really the x and y's are switched. Okay? I like to use this only, and you'll see why in my examples. So here's the first example. And I always circle or highlight. Okay? So this is why I circle or highlight. Because it says the derivative of the... So here's f of x. And they give you a point. So I don't even care what they say here. I'm going to ignore that. And then I want to know if this is on f of x. So how do I know if this is on f of x? If I plug in 2, do I get 8? Yes. So that means 2 is my x value here. And that's why I highlighted 2. If I plug in 8, I can just look at it and be like, nope, if I plug in 8, that's not going to give me 2. I know that for sure. Okay? So I highlight the 2. And then what I'm going to do is I'm going to find my derivative of f prime. And I'm looking for the derivative of the inverse. So I'm looking for g prime of 2. That's my x value of f of x. So that's going to be 1 over f prime of, I'm using that formula, 2. So see that 2, 2, 2. So 1 over, and then what's f prime of 2? Well, this is f prime, so I plug in 2 and I get 10. So 1 over 10. Okay, so another example. Similarly, let's say you have this. Let's say they don't tell you this part. So if they don't tell you this part, how do you know what to plug in? Well, this is your point. Let's say you don't even know what that means. But then again, if you plug in 8, do you get 2? No. If you plug in 2, do you get 8? Yes. So 2 is the one that gets circled. 2 is the one that gets highlighted. Okay. So I'm really still finding the derivative. I'm finding the 2 is the one that's the x value here. So 2 gets plugged in here, 2 gets plugged in here, and then 1 over f prime of 2, 2 gets plugged in here. Yes, the answer is 1 over 10. Okay, I'm going to show you with a different function. Are you ready? Different function. So they don't tell you what it's on. But then you look at this. If you plug in 10, do you get 1? No. You get like 1,000 something. I don't know what you get. If you plug in 1, do you get 10? 1 plus 7 plus 2. Yes. So 1 is your x value of this. So I highlighted 1. I don't really need to know this. I just can figure out by plugging in. Okay? So the 1 is the important part. I find the derivative, and then I use the 1, and then I use the 1 over f prime of, I plug in 1, and I get 10. Is the answer always 1 over 10? No, but you know, for now it is. How do you know if the point is on f of x? You literally plug in. So if it's not given, you plug it in. I don't even care if it's given. You plug it in. Go ahead and plug it in, and then, you know, circle something, okay? On the back, you're doing A, B, C, and D. So A, B, C, and D, the first thing you're going to do is you're going to highlight either the 0 or the 5, the 1 or the E, the 0 or the, well, it doesn't matter, so use the 0 anyway, the 1 or the 0. How do you do that? You plug in 5, do you get 0? I don't know. Plug in 0, do you get 5? maybe, then you highlight the 0. Okay, I'm going to give you the answers for A through D. And I want you to put all of them on the homework help line. Okay, so your homework is just, for now, it's A through D. Tomorrow, it's going to be the rest of them, and I'll give you these answers again. That's not a problem. But your answers for A through D are these. Go ahead and write the answers down. And then on your paper, you're going to do these problems just like we did these over here. And then you should get those answers, okay, for A through D. That's part of your homework for tonight. Okay, so good luck, See ya.